Imagine a cargo ship the size of a skyscraper, slicing through the ocean for years without ever needing to refuel. It sounds like science fiction, but China just unveiled a concept that could make it a reality. They're planning to build the world's most advanced nuclear-powered cargo ship, a massive vessel capable of carrying 14,000 containers. But here's the twist: it won't be powered by traditional uranium. Instead, it will use thorium, a cleaner, safer, and more abundant nuclear alternative. This isn't just a new ship, it's a statement. China is making a bold play to leapfrog Western shipping and energy technology all at once. By investing heavily in thorium, they're aiming for total energy independence and a new level of maritime dominance. If this ship sets sail, it could slash the carbon footprint of global shipping, enable long-term autonomous voyages, and completely reshape the rules of the sea. But the journey from a concept on paper to a reality on the water is filled with massive challenges. So, how does this futuristic ship actually work? At its heart is a 200-megawatt thorium molten salt reactor. Now, this reactor doesn't directly turn the propellers. Instead, it generates intense heat to power a supercritical carbon dioxide generator. This advanced system converts thermal energy into 50 megawatts of electricity with incredible efficiency, up to 50%, which is a huge improvement over the 33% efficiency of conventional nuclear steam systems. What makes this design so revolutionary is its safety. The reactor operates at normal atmospheric pressure and doesn't require water for cooling. This eliminates bulky, complex support systems and makes the ship much quieter and harder to detect. It even has a fail-safe mechanism. If the reactor overheats, the molten salt fuel automatically flows into a separate chamber where it cools and solidifies, trapping all radioactive material without any human intervention. The entire reactor module is designed to be sealed and operate for 10 years straight. After a decade, the whole unit is simply swapped out for a new one, minimizing maintenance complexity and radiation exposure risks for the crew. This incredible maritime project didn't just appear out of nowhere. It's built on years of research from a groundbreaking project deep in the Gobi Desert. There, China built the world's first land-based thorium molten salt reactor, which began stable operation in 2025. This pilot program proved that thorium could be a viable and powerful nuclear fuel. It was a huge milestone, one that researchers around the world have chased for decades. China's bet on thorium is also a strategic one. The country has vast domestic reserves of the metal, especially in Inner Mongolia. This gives them a secure, long-term fuel supply, freeing them from the volatile global uranium market. And this cargo ship is just the beginning. China is also developing other thorium-powered naval systems, including a massive oil tanker and even a floating nuclear power plant. They're not just building a ship, they're building an entire thorium-powered maritime ecosystem. Despite all the incredible technology, this ship is still just a concept. There's no construction timeline, and the regulatory hurdles are enormous. Getting approval for a nuclear-powered civilian vessel to enter ports around the world is a diplomatic and legal minefield. Cost is another major barrier. Nuclear-powered ships are fantastically expensive to build and operate compared to conventional ones. There's no established insurance framework, no internationally agreed-upon legal structure for liability, and a severe shortage of crews qualified to operate nuclear reactors at sea. And while thorium reactors are safer and produce less long-lived waste than their uranium counterparts, the idea of nuclear shipping of any kind makes governments nervous. The International Maritime Organization has yet to create a global standard for nuclear commercial vessels. Plus, no one has figured out a global system for transporting and disposing of used thorium reactor modules, raising long-term environmental questions that remain unanswered. The idea of using thorium to power ships isn't new. The US experimented with it back in the 1960s but abandoned the project due to costs and technical setbacks. Today, China's ambitious plan represents the most serious attempt ever to make thorium-powered shipping a large-scale reality. If they succeed, the implications are world-changing: near-zero emission shipping, unmatched strategic freedom at sea, and a new blueprint for safe, compact nuclear energy. The real test is whether China can translate a concept proven in the desert into a vessel that is seaworthy in every sense, technically, economically, and politically. The fate of this one ship could determine whether thorium remains a footnote in the history of energy or becomes the cornerstone of our future. The world is watching. Thanks for watching. If you found this interesting, don't forget to like this video and subscribe for more deep dives into the technology that is shaping our world. See you next time.